In this video, we'll cover nuclear reaction. A nuclear reaction involves the nucleus, like the proton and a neutron, or both. Now, the nuclear reaction, the reason why it occurs is because the nucleus itself is unstable. Because the unstable nuclei wants to become stable, it will go through what is called the nuclear reaction. As the nuclear reaction occurs, there's going to be some kind of changes either in the neutron or the proton or both, or maybe not even just a shift, just arrangement differences. There's going to be some kind of high energy radiation that will be emitted as the nucleus is changing. One type of a nuclear reaction is called the alpha decay. In the alpha decay, as highlighted in this first pink highlight, you'll see this is the nucleus and there's something that has been taken out. And that something is 2 protons and 2 neutrons. They've been taken out, and this clump together is called the alpha particle. It is denoted as such as follows. On the right, you could see radon 222. So this is radon 222, a radioactive material. It is an atom that might have some kind of unstable nucleus, and what happens is, so here's the arrow, and it spits out an alpha particle. An alpha particle is denoted as 4,2 helium or 4,2 alpha. Doesn't matter which one you utilize, one of these two will be very commonly used. As this is happening, because there was a change in the number of protons, the radon becomes polonium, PO. Now what do we lose? We lose 2 protons and 2 neutrons, which is very much like the helium. Now, this occurs in atoms that are very heavy and somewhat slow moving. So radon 222, that's quite heavy. That's more towards the bottom of the periodic table. Now, let's go ahead and do a learning check based on what we have learned so far. So here it says, show uranium-238 going through an alpha decay. So we're taking out an alpha particle. So I'm going to denote it as alpha, and then we will put 4 on top and 2 on the bottom. Now, what does this 4 and the 2 mean? The 4 means this 4 is the mass number. So it is the number of the proton plus the neutron. This 2 represents the number of the protons. So this is proton. So what this is saying is, hey, 2 protons are coming out. So what that means is that 92 will go down to 90. So plus 90. That means on the top, 4 has been taken out from that 238. So it should be 234. So what does that mean? What element is this? Well, the element has to be the one that represents by the proton number. And the proton number on number 90, if you look at the periodic table, thorium. So that's TH. Not sure if this is from the movie Thor, where they got Thor from thorium. Who knows? Anyways, this alpha particle has been taken out from an unstable nuclei uranium, and it formed into thorium. So this is less unstable. It means that it is stable in comparison to uranium. Now let's take thorium-232, decaying and emitting an alpha particle. So here I'm not showing an arrow. I'm not going all that route, but I'm asking you to show this entire thing starting with thorium-232. So here's thorium-232, means that's the mass number. And thorium has an atomic number of 90. So now this is going through a process of alpha decay. And so what is on the right side of the equation? Try this and come back. Here is the key. I want to make a quick comparison between the left side of the equation and the right side of the equation. The mass number in totality on the left side of the equation, there is 232, meaning there is the number of proton and neutron will equal out to 232. Whereas the proton number, well, is 90. And this is all from the reactant side based off of thorium, since there's only thorium. On the right-hand side, the mass number, well, one comes from the alpha particle, which is 4, and the other one comes from radon, which is 228. That will equate out to, if you add the two together, it will be 232. The proton number on the bottom is, well, from the alpha particle, there's 2, and from the radon, there's 88, and so there's 90. So if you look on the left side of the equation and the right side of the equation, the totality of the mass number, the totality of the proton should equal out. It means that whatever you have lost, well, whatever you lost plus what it formed into together will become is like where it came from, which was the thorium. That applies to the uranium too. Uranium, the mass number here is 238, and the proton number is 92. Well, on the right side of the equation, the mass number is from the alpha particle is 4, and then you have the thorium, which is 234, and then for proton, you have 2 proton plus the thorium 90, that gives me 92, and the top 238. So you see how the 238, 92, and 92.